Hello everyone, this is Ashutosh and today we are going to study is it visible? Regularize boolean set operations. Now let us understand what is boolean set operations. So boolean set operations are used to combine two objects like I have a circle and I have another circle. I want to combine the two objects, so that is O1 and that is O2. Okay, so if I want to combine, so these possibilities may happen. Like I want this part. So what do we say, intersection? Okay, so I may want whole part. I want to combine this object 1 and object 2, or I want to get this part O1 part only, or it may be possible that I want only O2 part. So these things happens in regularized boolean set operations. So boolean operations are of three types. Let us see. Boolean operations, so they are and, or, and not. So in AND we do intersection. Okay, just intersect. Okay, so here we do union, or in not I would explain later, because two things are there. Yeah. So in AND part, so like this, like we have studied in class 12th, we just find the intersection of the two objects like O1 and O2. In the case of OR, we want the whole figure, we want to combine the O1 and O2. Okay, so now let us study it in detail. Okay, so let us start with union. So let us write its definition: the sum of all points in each of two sets defined by logical OR. It says that sum of all points in each two sets are defined by logical OR. If I have object like 3D object like this cube, and I want to combine this with a cylinder, if I want to combine this, so these points this are defined by logical or it would they would combine. So this is, or if I combine this, A union B happens, or it would something like, it would look something like that. Okay, So now moving toward the I hope now it is visible. So next one is difference. So different we have also studied in our previous classes. So if I have shape like this cube and this cylinder, now the situation is like that. I want this cube and I want this cube only, like we like we do in a minus b. It would look something like that. So you can say that they are used to form the complex shapes. So if I want to reverse this operation, or I want it differently, so I can do something else like so. So now we would left with this part only. Okay, so sorry for my chin. Now let us write the definition for difference. So the difference is the points in a square set, square square set. I would explain, and minus the point common to a second set. They must share the common volume. They must share the common volume. So the definition says the point in a square set, okay, minus the point in the second. So likewise we have seen, okay. So here we do have a square, okay. So when it gets a common with this point, it should share the common volume. So likewise if it is a, it should share this volume, okay. So that's all about it. And now we would talk about intersection. So intersection is also really very simple. So it is, so like like when in our previous classes we do have sets, here we have objects. So we want this part, like we have some spares, so we can form a lens like this. So I would explain with the previous example itself. Okay, so if I have this cube object, and I want this common area. So this is object 1 and this is object 2. I want its a common area. So what is its common area? Yes, it is this itself. So likewise, as you can see, we would left with this. So it may also happen. So I have a note for you. So if you have a cube like this, okay, and you are trying to find the difference or apply the boolean operation like that. So as you can see, the common part is this only. So this would be a 2D image. So that the boolean operation we performed on the two 3D object should not be end with the 2D object. Okay, so this is the note that we should not follow this. Okay, so that's all about it. Thank you. Yeah.